Anticipated 50% investment surge in space exploration, astrobiology, and renewable energy sectors by Q2 2028. Overview. By the second quarter of 2028, significant investment increases, projected at nearly 50%, are expected across the sectors of space exploration, astrobiology, and renewable energy. This summary compiles insights from various reports and analyses that highlight the trends, forecasts, and implications for these critical areas of scientific and technological advancement. Space exploration. Investment growth. A report from Ivona indicates a robust upward trend in private investments within the space sector, which is anticipated to persist steadily through 2025. NASA's budget is projected to rise significantly, reaching approximately $26 billion in 2025, underscoring its commitment to missions focused on lunar exploration and sustainable off-world presence through projects like Artemis. Key investment areas. Private investment. By the third quarter of 2024, investments in space technology startups exceeded $3.5 billion, reflecting a growing interest in satellite communications, space debris management, and propulsion technologies. Employment projections. The U.S. space sector is expected to see a 5% growth in employment in 2025, driven by expanding subsectors such as satellite manufacturing and space tourism. The emergence of new roles in areas like in-orbit servicing and Earth observation analytics will further support this growth. Notable developments. 1. Artemis program. The Artemis program aims to establish a sustainable human presence on the Moon and is a cornerstone of NASA's future exploration initiatives. 2. Commercial investments. Major aerospace firms and private equity are increasingly investing in scalable and resilient companies, indicating a shift toward a more consolidated and efficient space industry. Astrobiology. Importance and funding. Astrobiology has emerged as a focal point within NASA's scientific efforts, especially with upcoming missions like Mars Sample Return and the Habitable Worlds Observatory. The community has rallied for increased funding to safeguard ongoing research, emphasizing its vital role in understanding life beyond Earth. Legislative support. The Transition Authorization Act of 2017 has reaffirmed astrobiology as a core mission of NASA, highlighting its significance in maintaining U.S. leadership in space exploration. The urgency of maintaining workforce and funding levels in this field is emphasized, as reductions could hinder critical scientific discoveries. Upcoming opportunities. 1. Transformative missions. Upcoming missions are set to explore Mars, ocean worlds, and exoplanets, which could answer fundamental questions regarding the existence of life beyond our planet. 2. Public engagement. The public's interest in astrobiology remains high, serving as a catalyst for increased STEM engagement and scientific funding. Renewable energy. Investment surge. According to a report from S&P Global Commodity Insights, investments in clean energy are anticipated to surpass those in oil and gas for the first time by 2025. Projections indicate an allocation of $670 billion toward clean energy technologies. Key trends in renewable energy. Solar energy dominance. Solar energy is expected to account for a significant portion of new capacity installations, driving overall growth in the clean energy sector. Battery energy storage. The demand for battery energy storage systems is projected to surge, essential for stabilizing power grids with high renewable penetration. Challenges ahead. Despite these encouraging trends, several challenges persist. International market pressures. Issues such as international pricing pressures from China and U.S. tariffs on solar cell imports could impact the growth trajectory of the solar industry. Manufacturing dynamics. The U.S. and European markets face challenges in ramping up domestic clean energy production in response to global competition, particularly from China. Common themes across sectors. 1. Investment growth. Across space exploration, astrobiology, and renewable energy, all sectors exhibit a surge in investments driven by technological advancements and global commitments to address existential threats such as climate change and the quest for extraterrestrial life. 2. Job creation. The anticipated growth in these sectors is projected to create numerous employment opportunities as companies expand to meet rising demand. 3. Technological innovation. Innovations in artificial intelligence for energy management and propulsion technologies for space exploration underscore the interconnectedness of these fields. Key differences in focus. While all sources agree on the overarching trends of growth and innovation, they differ in their specific focus areas. Ivona highlights the trends in space exploration and technology investments, particularly in private investment dynamics. NASA's report emphasizes the critical nature of astrobiology within its mission and the imperative of maintaining funding and workforce levels. S&P Global provides a thorough analysis of the economic dynamics and market shifts within the renewable energy sector. Timeline of events. 2024, record investments in space technology startups exceed $3.5 billion by Q3. 2025, NASA's budget is anticipated to reach $26 billion. Clean energy investments are projected to surpass oil and gas spending with $670 billion allocated. 2028, the culmination of these investment trends is expected with sustained growth in space exploration, astrobiology, and renewable energy. Conclusion. The anticipated investment surge across space exploration, astrobiology, and renewable energy reflects a growing recognition of their importance in addressing critical challenges facing humanity. With a strong emphasis on innovation, sustainability, and scientific discovery, these sectors are poised to play a transformative role in shaping the future of our planet and beyond. The trends identified set the stage for a new era of exploration and environmental stewardship, fostering a collaborative approach to the pressing challenges of our time. The anticipated 50% surge in investments across space exploration, astrobiology, and renewable energy sectors by Q2 2028 presents several counterintuitive insights that challenge conventional perceptions about these fields. Counterintuitive insights. 1. Space exploration as a growth catalyst. Contrary to the belief that space exploration is a niche or luxury sector, the data indicates that it is becoming increasingly integral to economic growth. The projected increase in NASA's budget to $26 billion by 2025 reflects a strategic pivot where investments in space exploration are viewed not just as scientific endeavors but as essential components of national economic competitiveness. This shift suggests that investments in space can drive job growth and technological advancements within the broader economy, which may not be widely acknowledged among skeptics of space spending. 2. Astrobiology's central role. Astrobiology is often perceived as a speculative science, but the reports highlight its foundational importance in NASA's mission. The urgency for maintaining funding and workforce in astrobiology underscores its practicality and potential for groundbreaking discoveries. The assertion that astrobiology could answer fundamental questions about life beyond Earth contrasts with the notion that such research is merely theoretical or disconnected from immediate scientific and technological advancements. 3. Renewable energy outpacing fossil fuels. The prediction that clean energy investments will surpass oil and gas spending for the first time in 2025 challenges the conventional wisdom that fossil fuels will dominate energy investments indefinitely. The anticipated $670 billion allocation to clean energy signifies a profound shift in global energy priorities driven by climate change commitments. This transition indicates that not only are renewable technologies becoming economically viable, but they are also poised to reshape global energy markets in ways that many industry analysts have not fully anticipated. 4. Technological interconnectedness. The interconnectedness of advancements across these sectors is noteworthy. Innovations in artificial intelligence for energy management and renewable energy can have implications for mission planning and space exploration. This synergistic relationship challenges the perception that these fields operate independently, rather they are increasingly interdependent, suggesting that investment in one area may yield dividends in another. 5. Public enthusiasm versus funding reality. Despite strong public interest and enthusiasm for space exploration and astrobiology, there is a paradox where funding is often precariously balanced against political and administrative pressures. The report highlights a call for support to safeguard funding for astrobiology, indicating that public passion does not always translate to sustained financial backing. This disconnect reveals a deeper challenge in aligning public sentiment with policy and funding decisions, particularly in a climate of budget constraints. 6. Challenges in clean energy growth. While projections for clean energy growth are optimistic, the report reveals looming challenges such as international pricing pressures and trade dynamics that could impede progress. The anticipated growth of battery energy storage systems and solar energy is tempered by the potential impact of tariffs and international competition, particularly from China. This complexity underscores that the path to renewable energy dominance is fraught with obstacles, contrary to the simplistic narrative of an unimpeded transition. 7. Employment trends. The expected job growth in both the space and renewable energy sectors is not merely a function of increased investment but also reflects a shift in industry focus. The transition from speculative R&D roles to operational efficiency and cybersecurity highlights a counterintuitive trend where the nature of employment is evolving alongside technological advancements. This may defy expectations that job growth in emerging sectors would primarily consist of high-tech roles. Instead, it requires adaptability and a shift in skill sets. 8. Legislative influence on research priorities. The legislative backing for astrobiology outlined in NASA's Transition Authorization Act of 2017 emphasizes that governmental policies can significantly shape research priorities. The notion that astrobiology is a core mission for NASA rather than a secondary concern suggests that federal support can pivot the focus of scientific inquiry towards more grounded and impactful research, challenging the idea that funding is solely driven by market dynamics. Conclusion. The anticipated investment surge in space exploration, astrobiology, and renewable energy sectors by 2028 illustrates a complex landscape where conventional wisdom may not fully capture the realities at play. The interdependencies among these sectors, the transformative potential of public enthusiasm, and the challenges posed by international dynamics all contribute to a nuanced understanding of how these fields will evolve in the coming years. As investments continue to grow, recognizing these counterintuitive insights will be crucial for stakeholders aiming to navigate the future of technology exploration and sustainability. The anticipated investment surge of approximately 50% in space exploration, astrobiology, and renewable energy sectors by Q2 2028 presents a transformative opportunity that warrants deeper scrutiny beyond the surface-level projections. Below, I will highlight several critical aspects of the report that are often overlooked along with their significance. 1. Astrobiology's role in NASA's mission. While many reports emphasize the growth in funding for space exploration and renewable energy, the unique position of astrobiology as a core component of NASA's mission often does not get the attention it deserves. The call to safeguard NASA's astrobiology funding and workforce is a crucial yet underappreciated element of this investment surge. Significance. Astrobiology is not merely a niche scientific endeavor, it underpins humanity's quest to answer profound questions about life beyond Earth. The upcoming missions such as Mars Sample Return and the Habitable Worlds Observatory are pivotal for scientific discovery. Maintaining strong support for astrobiology ensures that NASA retains its leadership role in this critical field. Without sufficient funding and workforce, the ability to conduct significant research and exploration could be jeopardized, leading to missed opportunities in understanding our universe. 2. Employment opportunities beyond traditional sectors. The report mentions projected job growth in the U.S. space sector and renewable energy but does not fully explore the implications of this growth across multiple industries. The intertwining of these sectors through technological innovation is a crucial element that may be overlooked. Significance: as investment in space exploration and renewable energy surges, ancillary sectors such as AI, cybersecurity, and materials science will likely experience growth as well. This interconnected growth can generate new career paths and diversify the job market. For instance, advancements in AI for energy management and propulsion technologies for space exploration can create a workforce that is not only skilled in space and energy but also versatile in applying these skills across various sectors. This cross-pollination can drive innovation and resilience in the economy. 3. Technological innovations. While the report identifies technological advancements as a common theme across the sectors, specific innovations that could redefine industry standards often do not receive adequate emphasis. The role of AI in energy management and propulsion technologies in space exploration are particularly noteworthy. Significance: the integration of AI into energy systems can lead to more efficient grid management and improved energy forecasts, which are critical as we transition to renewable sources. Similarly, advancements in propulsion technologies can drastically reduce the costs and increase the viability of space missions. Recognizing these innovations emphasizes the potential for transformative impacts that extend beyond their immediate sectors. Influencing global economic dynamics and environmental sustainability. 4. The economic dynamics of renewable energy. The expected surpassing of oil and gas investments by clean energy in 2025 is a pivotal moment that reflects a significant shift in economic priorities. However, the report doesn't fully dissect the implications of this shift on global energy markets or the geopolitical landscape. Significance: this transition is not just an economic statistic, it signifies a profound realignment of energy policies globally. The implications for oil-dependent economies, energy security, and climate policies are vast. Countries that adapt quickly to renewable energy technologies may gain a competitive edge in the global market, while those that delay risk economic decline. This shift also involves addressing challenges such as international pricing pressures and tariffs, which could reshape trade relationships and manufacturing strategies. 5. The impact of international dynamics on clean energy. The report highlights the influence of China's clean tech equipment oversupply and U.S. tariffs on solar cell imports, but may not fully capture the broader implications of these dynamics. Significance: the interplay between international trade policies and renewable energy investments is crucial. As the U.S. navigates its trade relations with China and Southeast Asian countries, the resulting policies will significantly impact domestic manufacturing capabilities and pricing strategies. This relationship will define the competitiveness of U.S. clean energy technologies in the global market. Furthermore, as nations like India ramp up their manufacturing capacities, the emerging dynamics could lead to new alliances or tensions in the clean energy sector. 6. Public engagement and support for space exploration. While the importance of public interest in astrobiology is mentioned, the broader implications of public engagement in space exploration and science are often underappreciated. Significance: public support is critical for sustaining funding and interest in space initiatives. Engaging the public through educational programs and outreach can foster a culture of innovation and inspire the next generation of scientists and engineers. This engagement can also influence policy decisions, as public enthusiasm often translates into political support for funding and initiatives. Leveraging this passion can help secure the necessary resources and political backing to sustain long-term projects in space exploration and astrobiology. 7. Interdependencies of sector growth. The report outlines growth in space exploration, astrobiology, and renewable energy, but does not delve into the interdependencies between these sectors, especially in the context of technological and economic development. Significance: Understanding how advancements in renewable energy can support space exploration, e.g., solar energy for power in space missions, and vice versa, e.g. Innovations from space technologies improving renewable energy systems can foster a more integrated approach to investment and policymaking. Recognizing these interdependencies can lead to more comprehensive strategies that enhance the overall effectiveness of investments across sectors, ensuring that advancements in one area can catalyze progress in others. Conclusion: the anticipated 50% investment surge in space exploration, astrobiology, and renewable energy by Q2 2028 presents a unique opportunity for transformative growth. However, the significance of various overlooked aspects, such as the role of astrobiology within NASA employment dynamics, technological innovations, international economic implications, and public engagement, cannot be understated. By recognizing and addressing these elements, stakeholders can better navigate the complexities of this investment landscape and maximize the potential benefits across sectors. Key points for in-depth analysis and discussion. 1. Investment surge across sectors. The anticipated 50% surge in investments across space exploration, astrobiology, and renewable energy sectors by Q2 2028 signifies a transformative shift in funding priorities. This trend highlights an increasing acknowledgement of the importance of these sectors in addressing pressing global challenges such as climate change and the exploration of potential extraterrestrial life. The convergence of government budgets, private investments, and public interest sets the stage for significant advancements in technology research and employment opportunities. Discussion points. What factors are driving this investment surge? How can governments and private investors collaborate effectively to maximize the impact of this funding? What role do public perceptions and global challenges play in shaping investment priorities? 2. Technological innovation and interconnectivity. The report emphasizes that advancements in technologies such as artificial intelligence (AI) for energy management and propulsion systems in space exploration are interlinked. Innovations across these sectors can lead to enhanced efficiency, reduced costs, and accelerated discoveries. For instance, the application of AI in renewable energy can optimize grid management, while developments in propulsion technologies can make space travel more feasible and sustainable. Discussion points. How can cross-sector innovations be fostered to maximize benefits in each field? What are the potential risks of relying too heavily on technological advancements without addressing underlying systemic challenges? In what ways can collaboration between sectors drive research and development? 3. Employment opportunities and workforce development. The projected growth in employment within the U.S. space sector and renewable energy highlights the potential for job creation as these industries expand. The report notes a 5% growth in employment in the space sector, driven by burgeoning subsectors like satellite manufacturing and space tourism. Similarly, the renewable energy sector is poised to create numerous jobs as investments in clean technologies increase. Discussion points. What strategies can be implemented to ensure a skilled workforce that meets the demands of these rapidly evolving industries? How can education systems adapt to prepare students for careers in these sectors? What role do public-private partnerships play in workforce development? 4. Challenges and regulatory landscape. Despite the optimistic outlook, the sectors face significant challenges, including regulatory hurdles, international pricing pressures, and trade dynamics. The renewable energy sector, for example, is grappling with the impact of tariffs on solar cell imports, while the space sector must navigate competitive pressures from emerging global players. The need for legislative support, such as the Transition Authorization Act of 2017 for astrobiology, underscores the importance of a stable regulatory environment. Discussion points. What regulatory frameworks are necessary to foster growth in these sectors while ensuring sustainable practices? How can industries and governments work together to address international trade challenges? What lessons can be drawn from the regulatory approaches of different countries in promoting innovation and investment? Conclusion. The anticipated investment surge in space exploration, astrobiology, and renewable energy by Q2 2028 presents a unique opportunity for transformative growth. By examining the interplay between investment trends, technological innovations, employment prospects, and regulatory challenges, stakeholders can better navigate the complexities of these rapidly evolving sectors. Engaging in thoughtful discussions around these key points will be crucial for maximizing the potential benefits while addressing inherent challenges. 1. The space race 1957 to 1975. The space race was a significant period during the Cold War characterized by intense competition between the United States and the Soviet Union to achieve major milestones in space exploration. It began with the Soviet Union's launch of Sputnik 1 in 1957, marking the first artificial satellite in orbit. The U.S. responded by accelerating its own space programs, culminating in the Apollo 11 mission, where NASA successfully landed humans on the Moon in 1969. This era saw unprecedented investment in aerospace technology and research, driving innovations that laid the groundwork for modern space exploration. The space race not only advanced scientific knowledge but also inspired generations to pursue careers in STEM fields. 2. The Manhattan Project 1942 to 1946. The Manhattan Project was a research and development project during World War II that produced the first nuclear weapons. Initiated by the United States with the support of the UK and Canada, the project represented a massive mobilization of scientific and financial resources, leading to significant advancements in physics and engineering. The project culminated in the successful detonation of atomic bombs in 1945. The urgency and scale of the Manhattan Project exemplified how geopolitical factors can drive rapid innovation and investment in technology, with far-reaching implications for science warfare and international relations. 3. The Green Revolution 1940s to 1960s. The Green Revolution refers to a series of research, development, and technology transfer initiatives that significantly increased agricultural production worldwide, particularly in developing countries. Pioneered by scientists like Norman Borlaug, the Green Revolution introduced high-yielding varieties of cereals, synthetic fertilizers, and advanced irrigation techniques. This movement was marked by substantial investments from governments and organizations aimed at enhancing food security. The Green Revolution not only transformed agricultural practices but also served as a model for how targeted investment in technology and research can address global challenges like hunger and poverty. Future outlook. Anticipated 50% investment surge in space exploration, astrobiology, and renewable energy sectors by Q2 2028. By the second quarter of 2028, a significant transformation is expected across the fields of space exploration, astrobiology, and renewable energy, with a projected 50% surge in investments. This anticipated growth signals an intensified focus on innovation, sustainability, and scientific discovery, driven by both public and private sectors responding to urgent global challenges. Below, we provide a detailed prediction of the future landscape for these sectors. Space exploration. The space industry is on the cusp of unprecedented growth, fueled by a combination of government backing and private sector enthusiasm. NASA's projected budget increase to around $26 billion in 2025 highlights a commitment to ambitious missions such as Artemis, which aims to establish a sustainable lunar presence. Following the trends observed in 2024, private investments in space technology startups are expected to exceed $3.5 billion annually, targeting areas like satellite communication, space debris management, and space tourism. By 2028, we anticipate a robust ecosystem characterized by 1. Increased collaboration, an uptick in partnerships between government agencies and private enterprises, leading to more efficient project executions and sharing of technological advancements. 2. Job creation. Employment in the U.S. space sector is likely to expand by over 15% from 2025 to 2028, driven by growth in satellite manufacturing, space tourism, and in-orbit servicing. 3. Technological advancements, innovations in propulsion systems, AI for mission planning, and sustainable technologies for extraterrestrial habitats will redefine the capabilities of space missions. Astrobiology. Astrobiology is set to play a pivotal role in the next wave of space exploration. NASA's commitment to missions like Mars Sample Return and the Habitable Worlds Observatory positions astrobiology at the forefront of scientific inquiries about life beyond Earth. The field is poised for a renaissance with the following predictions. 1. Funding stability. Legislative support such as the Transition Authorization Act is expected to ensure consistent funding for astrobiology research, allowing scientists to pursue groundbreaking discoveries without the threat of budget cuts. 2. Interdisciplinary research. The future will see increased collaboration between astrobiologists, climate scientists, and engineers to develop technologies that not only search for extraterrestrial life but also address Earth's environmental challenges. 3. Public engagement. The public's fascination with the search for life beyond Earth is anticipated to drive funding and support for astrobiology, resulting in a surge in educational outreach and STEM engagement initiatives. 4. Technological spin-offs. Discoveries in astrobiology are likely to lead to technological advancements that benefit other fields such as medicine and environmental science, fostering a cycle of innovation. Renewable energy. The renewable energy sector is on the brink of a major transformation, with projections indicating that investments will surpass those in fossil fuels for the first time, reaching approximately $670 billion by 2025. Key trends expected by 2028 include: 1. Dominance of solar energy. Solar power is anticipated to account for over half of all clean energy investments, with significant advancements in photovoltaic technologies and energy storage solutions paving the way for a more resilient energy grid. 2. Battery energy storage growth. The market for battery energy storage systems (BESS) is predicted to expand dramatically, becoming critical for managing the intermittency of renewable sources and stabilizing energy supply. 3. AI integration. The integration of artificial intelligence in energy generation forecasting and grid management will enhance efficiency and optimize the use of renewable resources, leading to lower costs and improved reliability. 4. Global shifts. Geopolitical dynamics will influence the renewable energy landscape, with countries like India ramping up manufacturing capabilities to meet domestic and international demand, while trade tensions reshape global supply chains. 5. Policy and regulation. Continued government support through incentives and regulations will accelerate the transition to renewable energy, enabling a more sustainable energy future. Conclusion. The anticipated 50% investment surge in space exploration, astrobiology, and renewable energy by Q2 2028 reflects a collective recognition of these sectors' critical roles in addressing existential challenges. As we move toward this future, the interplay between advancements in technology, public interest, and supportive policies will be key to unlocking the full potential of these transformative fields. Increased investment will not only drive economic growth but also foster a more sustainable and scientifically informed global society, positioning humanity for a resilient and innovative future.